Nice meeting everyone. And again, thanks Monica, thanks Josephine for this opportunity to present some of the works that we are working on fiber reinforced polymer composites. Yeah, obviously at the University of Southern Queensland, we are also working on other materials, but probably that will fall with other working group. I titled my presentation more on FRP composites, and we believe that this is one of the low carbon emission materials, and potentially will fall under this working group on other materials. And yes, before I go through my presentation, I would like to acknowledge the traditional owners of the land on which I'm presenting today, and also would like to pay respect to elders past, present, and emerging. Probably for the benefit of everyone who are not that familiar with fiber composites. So we normally call this, especially in engineering and construction, as fiber reinforced polymers, which is a combination of fibers and they are combined with polymer matrix. So fibers can be made from carbon fibers, glass fibers, aramid fibers, and at the moment at UNESCO, we're also working on developing biocomposites or composites made from biofibers as well as bioresin systems. And in composites or in FRP composites, fibers provide the strength and stiffness, and the matrix or the resin binds and protect the fibers from being damaged and transfer the stresses between these fibers so that they can act as a composite system. So some of the advantages of fiber composites, they are high strength, obviously depending on the fibers that we are utilizing. They're significantly lighter in weight compared to traditional materials. Sometimes we can engineer them to mimic the behavior of other materials. They are non-corrosive, and also they offer rapid and economical construction. So some of the profiles that can be, or sections that can be produced from fibers and resin, they can probably mimic some of those profiles that we normally or traditionally use for steel. And they can also come in different forms, let's say in laminate, in section or tubular forms. So I just probably going to share on our, let's say, the main drivers for FRP research at UNESCO. Because of obviously significant with the climate change, we have seen significant deterioration in a number of our infrastructure. So some of them are provided here. We are seeing those UV damage in our concrete pavements, corrosion in our residential balconies, especially in the coastal or aggressive environment. Deterioration of timber sleepers as well for in railway line. Obviously, significant steel corrosion in concrete bridges, again, in aggressive marine environment, corrosion in pipelines, and again, deterioration of timber bridges, especially this is common in regional part of Australia. We are also working extensively with our transport, the Queensland Department of Transport and Main Roads because of that recent experience that we had. So last year, probably everyone is aware of this significant flooding that has occurred in Queensland and New South Wales, which claimed more than 5.5 billion of infrastructure damage. And they have reported that this flooding is now considered the number or second worst disaster in the history of Australia. And they're also predicting that extreme weather events will threaten more than 226 billion of our infrastructure throughout Australia. So the works that we are doing in UNESCO, obviously we are focusing on engineered fiber composites, but also we are also working on some cementitious or concrete materials, working with asset owners, with industries, as well as obviously doing those research and developments in a number of areas, especially in new construction and also repair of critical infrastructure. So some of our project focus on the following. So these probably more specific to FRP composites. So we are working on FRP. Again, FRP is fiber reinforced polymer pultrusion. We're also developing a number of polymer sleeper products using composites for repair and rehabilitation. And currently, we have a significant program on using fiber reinforced polymer as an alternative to steel reinforcement, again, to minimize corrosion or eliminate corrosion, especially in aggressive environments. So at UNESCO or in most universities, obviously as an academic, we do teaching, we also do research, and most of the research that we are doing on engineered fiber composites, so they are being conducted within the Center for Future Materials, and most of our research we are delivering research to reality. So we are working with a number of industries, really understanding what they need and developing our research activities to address those research needs. So probably the numbers on the right side of the slide just provide on the extent of the activities that we are doing within our Center for Future Materials. So we have over 100, sorry, not 100, 1,000 industrial test clients. So these providing them with collaborating with them in delivering our research, but also providing testing in the products that they have developed or developing. So UNESCO has, in collaboration with two companies, Wagner's Composites Fiber Technology as well as LOC Composites, we have developed the Australia's first FRP bridge. So again, so this is in response to the deteriorating timber bridges in a number of networks in Queensland. And as I mentioned, a number of these timber bridges, especially in regional parts of Australia or in Queensland, they are deteriorating. But it's now very difficult to obtain those large cross-section of hardwood timber. So with composites, we can engineer them to behave like that of timber, and that is very important, especially when we are doing this maintenance of this aging infrastructure or asset, where if you're going to replace only one of those damaged or aged timber, then you need to have the replacement material to behave or to have a stiffness similar to that of timber, so that when you replace that damaged part, then you'll have this good distribution or redistribution of forces amongst them. So from that research, we are continuously engaging or collaborating with Wagner's, providing or developing new profiles for their products. So we have an advanced manufacturing facility also at UNESCO, pultrusion, or let's say pultrusion machine, and filament winding as well. So these are the most common types of manufacturing process in producing these pultruded profiles. But obviously, in addition to manufacturing, we do a lot of experimental testing and numerical modeling as well to really come up with an optimized design. So these products are now being used in a number of construction engineering applications. So for cross arms in electrical poles, similarly for electrical poles as well, for pedestrian bridges, both in especially in aggressive environments, and not only that, obviously looking on bridge infrastructure as well in marine or aggressive environments. We have worked with Ostrak. So Ostrak is the #1 supplier of pre-stressed concrete sleepers, but because they have identified the significant market for composite alternative, then we just completed a CRCP funded project with them to develop a composite railway sleepers. So again, railway sleepers is that horizontal beam that you will see in a railway network that supports those rails. And similar to what I mentioned, in the rail network of Queensland Rail, they are now having difficulties purchasing or procuring those hardwood of high quality, which they normally use or traditionally use in supporting rails. So in collaboration with OSRAC, we have developed that fiber composite railway sleepers. And in that development, obviously, we have used fiber composites in areas where the stresses are high because of their high strength, but also we have used some waste materials like fly ash, crumb rubber, and also some waste plastics in areas where the stresses are low, so that we can have a balance of let's say good performance for the technology, but also utilizing some low cost materials to come up with a cost competitive technology or product. So again, in collaboration with the Queensland Rail, a number of these technologies have been or currently being trialed in a number of their network, and Austrac is now commercializing as well this technology, selling not only in Australia but also overseas. We have worked also in with one company based in Brisbane in developing this easy fit and self-locking composite jacket for repair of damaged piles or it's. But the novelty of this work is so okay. So fiber composites, we can utilize the high strength properties of fiber composites if we have continuity of fibers. But obviously, if we are doing structural repair, especially in marine environment, current methods, they're using the existing materials. But what we found there is if we're going to use the existing materials, they will be subject or they'll be exposed to the same environment that causes this deterioration to the structure. So by using composites being non-corroded, obviously we can minimize that deterioration. But to ensure that continuity of the fibers, so what's innovative in this particular product or technology is we have developed that self-locking mechanism similar to a zipper, where once you deliver that prefab jacket on site, you zip them so that you'll have that the system will provide continuity and will increase the stiffness as well as the strength of that repaired infrastructure, as we have demonstrated both experimentally as well as numerically. We are also collaborating with international institutions, let's say the University of Colorado in Boulder, Cornell University, and Gas Technology Institute based in Chicago, where we are developing composite repair systems for their gas and water pipelines. So this particular project is funded by the Department of Energy in the USA. I mentioned that one of the significant research programs that we are implementing at UNESCO is the use of fiber-reinforced composite rebars as an alternative to steel rebars, especially in aggressive environment, as a reinforcement to concrete structures in exposed in aggressive environments. And this is motivated by that report published by Osros in 2016, where they have found that most of our concrete bridge infrastructure starts to deteriorate only after 30 years of service. So keeping in mind that these critical infrastructure are designed to have a service life of at least 100 years. But because of this corrosion of steel, especially again in aggressive environment, then it's good to find an alternative reinforcement that can minimize or eliminate that problem. I mentioned that corrosion is a significant issue in coastal or marine environment, but from that work conducted by probably your colleagues, Josephine from University of Newcastle, where they found that the risk of corrosion will also significantly increase not only in coastal but also in inland parts of Australia because of climate change. Obviously, increase in temperature, increase in moisture. So those are the ingredients that can accelerate the corrosion of steel reinforcement. So from obviously we do a lot of research and development to demonstrate to our engineers and asset owners the benefits as well as the performance of concrete structures when they are enforced with GFRP bars. And from those experience and knowledge that we have generated or obtained, it has helped us in proving or demonstrating to a number of asset owners the benefits of using non-corrosive and high-strength reinforcement in a number of actual projects. So the pin can be warped in Brisbane. So these the largest use of FRP bars in Australia in a single job, so 305 kilometers or approximately 152 tons of GFRP bars were used in building this wharf. The Molecular Horizon building in the University of Wollongong in New South Wales have also specified the use of GFRP bars, not only from the point of view of being non-corrosive, but this particular building will house multi-million equipment which are very sensitive to electric as well as magnetic interference. So that's one of the benefits of using composites because they are electric neutral as well as uh, magnetic neutral as well. I mentioned that we are collaborating extensively with the Queensland Department of Main Roads, especially their maritime safety, uh, the Maritime Safety Queensland under TMR, where a number of their assets are deteriorating. So, during the implementation of one of the projects that we have implemented with them, we also documented the overall activities, and we found that GFRP bars not only provide that non-corrosive, let's say, performance of their assets, but also it will eliminate or will reduce the labor requirements being lightweight. Then then we can eliminate the use of forklift in handling them compared to let's say traditional reinforcing materials being heavy. Then they need a forklift and a forklift operator during handling and also transporting those reinforcing assembly. But by using GFRP bars, then they can be manually handled by let's say laborers. So from this, then TMR has now published technical specification for GFRP reinforced boat ramp planks, and they are now encouraging or promoting that all new boat ramp planks that will be built in Queensland will be reinforced by this non-corrosive reinforcement. So so building from that collaboration, so Queensland TMR is also now supporting a number of our fellows through Advanced Queensland Interest Fellowship, obviously in collaboration with industry partners and with TMR in future-proofing the Queensland infrastructure with composites as well as concrete technologies. Again, looking on a number of applications where we can maximize the use of these, maximize the benefits of these technologies. So so some of the projects or applications that we are working on. So approach labs, that piled boat ramp, which we're going to we just received good news last week that the Cassowary Council near Keynes has now approved the funding for this exemplar project. So this boat ramp project will be constructed specifically using composites as a reinforcement to concrete, as well as a number of components of this will be made of pultruded composite profiles. So we are also working with the Gold Coast and the Sunshine Coast City Councils in developing protective seawalls using composites. And again, with transport, Queensland Transport and main roads looking on precast concrete marine piles reinforced with GFRP bars. Working with a number of industry partners, with Inconmat based in South Australia, Humes Holcim based in Queensland, Graphene Manufacturing Group, and Zero Waste Matters. We are successful in in a project funded by CRCP on advanced reinforcing materials for to increase the longevity of Australian infrastructure. So the research that we are going to do as part of this work is we are using, or we're going to use bio-epoxy resin systems as a resin or a binder system to these to glass fibers to make the product more sustainable and obviously more more carbon emission by using more bio-based materials, but also bringing the circularity where we're going to use waste glass as the sun coating on the surface of the FRP bars. So sun coating is important so that you can promote the adhesion between your surrounding concrete and reinforcement. But at the same time, you're also utilizing waste plastics in developing clips to tie together this FRP reinforcement. And obviously working with the transport and main roads, looking on how we can use this reinforcement in a number of critical infrastructure. So we're looking on ballastless truck reinforced with GFRP bars, obviously working closely with ARTC, Australian Rail Truck Corporation. Probably you're well aware of that inland rail that will connect Brisbane to Melbourne, and there's a 6.1 kilometer tunnel that will be built as part of that project, which is will be constructed just at the backyard of UNESCO or in the near the Toowoomba bypass. So in addition to those developments, UNESCO is also actively involved in developing standards and specification for composite rebars. So we are now in the stage of public commenting, and I would imagine that a number of organizations involved in MELCA are has or have provided comments to these draft standards for FRP bars. But in parallel, we have worked with the Transport New South Wales as well as the Queensland Transport and Main Roads in developing a technical guide as well as a material specification for them to be able to start specifying the use of these reinforcing materials in their infrastructure. We are also providing education and training. So let's say at UNESCO, we have an online course providing practicing engineers as well as senior engineering students on the mechanics and technology of fiber composites. And every now and then, delivering technology workshops to practicing Australian engineers to provide them with knowledge necessary to design concrete structures reinforced with GFRP bars. And working with one of our industry partners in developing a design software for let's say concrete structures when they are reinforced with FRP bars. So really, these are the activities that I believe that UNESCO will benefit being a member of MELCA, let's say this type of activities, and obviously with working with a number of industry with organizations who are also member of this working group in disseminating and probably getting that feedback and sharing their knowledge on this new type of technology so that we can improve it further. So this is just probably more on to summarize the activities that we are working on UNESCO and also our industry partners in creating a climate resilient infrastructure and adaptive technologies research hub. Obviously, we are focusing on net zero infrastructure, also working on carbon neutral manufacturing, extensively working on those carbon capture construction and building materials to create that climate resilient infrastructure. So these are some of the organizations that we hope to participate during that event that MELCA is planning to organize in Brisbane next month. I think that's basically it, and very glad to hear any questions or feedbacks from others. Thank you.